Okay, we only have a few concepts left in this unit in physics. And because days are getting short, one of them is quite big. It's called complex circuits, and we're going to need Monday and most of Tuesday to do it. The other ones, there's 4 others, are really pretty quick and simple. So I thought I'd do a video on internal resistance, and then a separate one for the other 3. And then you can look at them at your leisure, and we can cover them briefly before the test and exam, and it should help us with time. So I'm looking at the last page of notes and all the notes that I gave you. The very last sheet I gave you has questions, but so this is the second last sheet, okay? And at the top on the front it says internal resistance of the power supply, and that's what I want to talk about right now. Okay, remember we said that everything has some resistance, wires and all of that, but that also includes power supplies, batteries. So you can pick up a battery, and this is a AA battery. You can buy one at the store, and you will see on the side that it's marked 1.5 volts. So in theory, this battery should be able to, when you hook it into your circuit, give you 1.5 volts of voltage to use in your circuit. In theory. In real life, that doesn't happen. And it doesn't happen because inside the battery, there is actually, sorry, I'm not lined up. There is actually a tiny little resistor. And that tiny little resistor takes some of the 1.5 volts away from the battery, leaving you with less to use in your circuit. Okay, so if this is my battery, then inside here we have this piece, which is 1.5 volts, but we also have a tiny little resistor. And because it is small, we usually, we always call it little r instead of capital R, because it's a small voltage, a small resistance. And so the voltage that this resistor uses, V, and we usually call it VINT for internal voltage, it's just going to be equal to Ohm's law IR, but the R is a little r. And so when I hook this battery into a circuit then, and maybe this circuit has 2 or 3 resistors in it, maybe a lamp, maybe my laptop, okay, so I hook it in here, and now current flows. As soon as current flows, this 1.5 volts that the battery is supposed to have loses some of the VINT, and so it's only the difference in these that's left for your circuit. And so we talk about something that's known as terminal voltage. In other words, the voltage across the terminals of the battery. It's also like the voltage of the source, because we have to take out what it's losing to the internal voltage. So we call it Vs. And the voltage of the source is going to be equal to this voltage minus the VINT. Now this voltage, the voltage that's written on the outside of the battery, it's called the EMF. And Science 12-2 people, you should recognize that as electromotive force. And that comes from way back when they didn't realize it was a voltage. They thought it was a force that was causing the current to flow. So it's really just a voltage, and its symbol in our equation is just a small script E. And so our equation becomes V terminal voltage, Vs, is equal to the EMF minus VINT. Okay? So this is the voltage that the circuit actually gets to use, known as the terminal voltage. This one is the voltage that's written on the outside of the battery or the power supply. It's what it was, what it's being sold as. So that for this one, it's 1.5 volts. It's set. It doesn't change, okay? So once you know this, it doesn't change. And then this one is what's being lost to the internal voltage of the battery. Now this one changes. It changes because even though the R is a set value, The I isn't, right? So this is equal to IR, and so the R is whatever it is, but the I changes depending upon the circuit you put it in. If you put it in a circuit that ends up having a really huge current, then this I is going to be big, and so the VI and T that you're losing is going to be big, and it's going to leave you with less voltage for the rest of your circuit. If you put it in a circuit where the current is small, then the V equals IR, the VI and T is going to be tiny. You'll be losing less voltage to it, and so you'll have more voltage left to use for the rest of your circuit. Okay? So there are two questions to do with this topic. They are on page 731, questions numbers 38 and 39. Give them a try. They're really pretty simple. The only challenging part sometimes people find is knowing which V is which V. So go in to see if you can figure out which one's the EMF, which one's the internal voltage, which one is the voltage of the terminals that you're using in your circuit. Okay, and we will go over them Monday or Tuesday or sometime before the end of the course. Thank you.